Welcome back, friends. We don't feel comfortable calling this a curve stablecoin until it utilizes some higher level math. So let's show off some of Vyper's higher level math capabilities. In order to pass the tests for this unit, we need to create a working getDy function. You might be thinking, whoa, fancy math already. You might remember dy stands for change in y using algebra. The function getDy means for however many tokens we put in, how many tokens can we get out? In this case, we're going to be putting in some curve, and we like to figure out how much crvUSD we can get out. And fortunately, our formula we're going to be attacking is pretty simple here. We'll go ahead and open up our minter.vy contract, and let's get our tests running here, because I'd like to have a terminal window open. The formula is simply going to be three parts. We're going to take the dx, how many tokens are we putting in? We're going to multiply this times the current price of curve, and we're going to multiply this times a parameter we're going to call the collateralization percent. When referring to collateralization percentage, if we assume that the price of curve is $1, you could mint exactly one crvUSD if you're using 100% of the collateral. But then if the price dips below $1, you might be immediately subject to liquidation. So lower numbers than this are less risky. If you were liquidating it, for example, 50% collateralization, then you could only mint 50 cents, but you'd be a bit safer. For the sake of simplicity, we're going to hard code this, but other types use much more complicated collateralization percentages. We might let you adjust this. We have a choice here. What sort of variable should we do this? We're talking about a percentage. So one of the ways we could do this is using Vyper's built-in decimal type. Solidity has reserved this fixed for future floating point types. It's not yet active. Vyper already has it active where you could work with decimals. And this is one potential way you could do this. But there are some issues in some cases in running decimals into integer math. And we've elsewhere been using integers. So let's build this out as integers, which is pretty common. If you read over a lot of smart contracts written in Vyper, what they tend to do is if you're dealing with decimals, they'll just multiply everything times 10 to the 18th, shift it over 18 decimal places, and then divide it by 10 to the 18th when you need to back solve it to decimals. We're going to take this approach as well. And in doing so, let's walk through some of the peculiarities that we need to watch out for when we're dealing with math. So looking over this TestMath.vy, let me go ahead and launch this here. And I've created, when I initialize this, 4 different basic mathematical functions. The first is just, let's assume that the current price is 69 cents. And we would like to represent this. Now, of course, this is going to fail because we're dealing with a uint 256 and we're trying to deal with a decimal. So if we actually call this coin price 1, you can see that this is obviously less than 1, so it rounds down to 0. By default, we're using integer math. So thankfully, all the Vyper arithmetic operators look exactly like Python arithmetic operators. Just note that when you're dealing with uints, you're going to have to deal with division that's integer division. So technically within Python, you would use double slashes to represent integer division, but it's the default when you're dealing with integer math. If you would like to use this decimals, what you're going to have to do is you're going to have to actually pass the decimal types as 0.0 and 0.0. This is just a way that Vyper makes it exceptionally clear that you're dealing with decimals. So if I was trying to define coin price 2 as 69 divided by 100 without the decimals, it would not work. But if I do it like so, then it's returning back a fixed 0.69. So not too bad. Now what about this third one? This third one looks like it should be fine according to the order of operations in mathematics. Obviously, if we take 69 cents and then shift it over 18 decimal places, you would hope that that would be 69 times 10 to the 17th or 16th. But in fact, because this first one is evaluated going left to right, this means that you're first completing this one, which gets us to 0, and taking 0 and multiplying it by 10 to the 18th. So coin price 3 is going to evaluate as 0. Unusable. Basically, the trick to remember when you're dealing with Vyper, or even Solidity for that matter, is make the numerator really big and then divide to make it smaller. So in this case, we're first going to expand the numerator to 18-digit decimal places, and then we're going to lop off 2 of them. And this is going to get us to our representation of 69 cents. In this case, it is a very, very big number, but we know that if we ever then in the future divide it by 10 to the 18th, we get back to a number we can use. So we can use this just as long as we remember to ultimately back it out by dividing by 10 to the 18th. One thing you have to be careful of, though, when you're making your numerator really, really big, there can also be some overflow in the numerator. So by way of example, this test overflow is, in theory, we would think that this mathematics is going to be under the limit. By that I mean we've defined this as a uint 256, which means that the max is 2 to the 256 minus 1. That's the max value. It's a very, very big number, so it gives you a lot of leeway to deal with things. Notice like this dwarfs in comparison with this. But if we're running, let's say this is t.coin price 4 to the 5th, and then dividing by 10 to the 18th, this is well below the maximum. But if we actually try and call it from the smart contract, it's going to revert. And the reason for this is that the numerator got too big. When you run just t to the coin price 4, t coin price 4 to the 5th, that is false. So it triggers a revert at this point, and it never gets around to executing it. So you need to make sure when you're dealing with this math that you're not going to be doing these overflows. Note that this is built into Vyper. There's no there's no need to like import a safemath library. Safemath comes built in by default. So these are some basic things to know when you're dealing with Vyper math. With this in mind, let's go ahead and fill out the rest of our smart contract. Again, we're saying we're doing a uint 256. You can use different numbers for this. It's pretty common to use 256 for a lot of things. It has to be a multiple of 8, whatever you do end up picking. And then let's pop down below our first internal function here. And let's go ahead and add a new internal function for getDy. Which is going to accept a uint 256 of quantity. And then we're going to run some math here. Then after we're done, we're going to add a new external function that's going to be the public-facing getDy. This one we'll give some doc strings for, and it's simply going to call the internal getDy function for the quantity that's passed. So our doc strings will include a notice that this is going to get the amount of stablecoin for a deposit of curve. Our only param will be the quantity, the number of curve tokens to deposit, and our return will be the number of crvUSD stablecoins returned. Now within our getDy, let's keep what we just learned about math in mind as we flesh this out. So we said that the math is pretty simple. We take quantity, multiply it by the collateralization percent, and multiply it by the price in USD. So we'll divide this up into a couple of variables so as to never have things get too big, never have things get too small. We'll create an internal variable for just this function called liquidation price. This is simply the price USD times the collateral percent and divide by 10 to the 18th. So our price USD, if we call this the minter, you can see the current price being returned is one of these big numbers, but divide by 10 to the 18th, and it makes sense, 64.8 cents. If you're watching this in the future, you might be wondering what's going on. It's been a crazy period in crypto here. So this number multiplied by the collateralization percent divided by 10 to the 18th gets us to essentially this big number times 10 to the 18th. In other words, minter.price USD times minter.collateral percent, which is, we're going to set this as, let's say, 0.8. Then divided by 10 to the 18th gets us to, at 52 cents is when this gets liquidated. So then all we need to do is return the quantity times the liquidation price divided by that 10 to the 18th, and we are set. We also need to set the collateralization percent. Using the same principle. Again, if we do 4 divided by 5 times 10 to the 18th, then this is going to evaluate to 0. So we do it in reverse order. We'll take 10 to the 18th, multiply by 4, and divide by 5. Finally, let's change our mint function. We used to just mint whatever the quantity was. In this case, we're going to mint just the outcome of this internal get dy on quantity. This is going to make sure that we're using the exact same function for minting that we're using for running this calculation. And I like to throw some typos in, but let's see. Compiled. So we hope that this has been a helpful exercise in understanding some of Vyper's mathematics capabilities and some of the things you might want to watch out for. You'll find that if you do want to do more advanced math with Vyper, there's a number of useful functions already built in, as well as some useful libraries for calculating some of the more complex mathematics that you might want to run across. So if you're trying to build some mathematics and you don't see the function, note the tests are passing here. If you don't see the function already built in, just go ahead and ask in the Vyper Discord, because odds are good someone has already built something out. So feel free to ask any questions as well in the comments. We are looking forward to hearing from you. As always, stay safe.